All right, let's take a look. You're going to stay. Okay. 3, 3, 15. This here?
Yeah.
All right, now, I love it. Because I don't think we've... Okay, so let's do an example like that. Let me make sure what it is about this problem that's tripping you up. So if I had this function here, let's see if this is going to work. Okay. And I have to take this guy's derivative. What is the main overriding rule there? Product rule. How many things are being multiplied? How many functions? How many? Let me see. 1, 2, 3. We haven't directly done like a triple, but it's the same process. Everybody gets a turn, right? So to do this, I would do the derivative of the first dude, and then the other guys stay the same. Then the first guy stay, Jeff, derivative. And then the derivative of the second dude. And then the derivative of the last dude. Right? Is that all right? And that is now not too bad. Or just to finish this out, 2x, e to the x, all this crap, plus, and of course this is beautiful. What's the derivative of that? Yeah, you gotta love e to the x. And then this guy, what's this guy gonna involve? Let me put him down here. Holy shit, Jeff. A plus sign goes like that. Okay. X squared e to the x. Yeah, this is going to be a chain. So 7 comes down. And then times the derivative of the inside. Hopefully I can just make it a 3. And then you clean it up. Okay. And depending on what you have to do next, you might want to factor this or whatever. But if this is the end, you just do a little bit of cleanup and you're done. So coming back to the actual question.
Well, the chain rule is in 3.4.
Oh, don't worry about it. I'm sorry. Is there any chain rule involved on this?
I'm going to say no.
Of course you can. Can somebody else say no? Can anybody safely say no? There's no chain rule? Is there any function inside of another function that's not just the variable? No, they're all thetas, right? So that's my fault. I made a more complicated problem. The main thing I wanted to show you with my example was how do you handle something that's a product of more than two things? It's the same rule. You just keep going. You just keep adding more and more plus parts. Yeah. Okay. All right. Yes. 3-1? 69. Okay. You guys are making me worried about my hearing. Let me see. I've already down to one eyeball. I'm always worried about my hearing going. All right. Ooh, yeah, this is awesome. Does anybody else try this one yet? Does it look familiar to anybody?
I'm doing that right now.
Oh, okay. All right, this is timely. All right. They want you to find a function. How many unknowns are in this function?
4.
4. That sounds exciting. The more unknowns, the worse it's going to be, right? But they do tell you it's got horizontal tangents at these points. What does that mean?
Means the derivative is 0.
The derivative equals 0 if I plug in a
X,
negative 2 for x, and if I plug in a 2. So then I get 2 pieces of information. Does that make sense so far? No? All right. Sorry. So, the main thing here is the only thing I know is that there's horizontal tangents at these points. That's all they tell me, besides, of course, it's cubic. So, of course, what's the very first thing I'm going to do with the function? Like you just said, it's all involved. The only information I have is about the derivative, right? The slope. So take its derivative, and what is the derivative equal if I plug a negative 2 into it? It has to equal what? 0. Yes, because there's a horizontal tangent line when x is negative 2. So if you take this guy's derivative, So this is backwards from normal, correct? If I gave you a function that said find out where the tangent line is horizontal, what would you do? You would take the derivative, set it equal to 0. Here, they didn't really give me the whole function, did they? They didn't really give me the function because I don't know what the hell a, b, c, I don't know what the coefficients are, but they did tell me where it's equal to 0, so it's sort of backwards, right? I normally try to find out where it's equal to 0, and these guys told me where it is equal to 0. Okay, all right, let me do one little piece of this, because I still got people looking at me like I'm insane, which I'm used to. Let me write this down. Here's the function. All right, it's just a normal thingamajig. What's the derivative? Yeah, 3ax squared.
And 2bx.
2bx plus c. Uh-oh, shit. Now we're all worried about our eyes. There we go. And again, this equals 0 when what is true? Give me one place where that equals 0. If if x is -2. So there's one thing I know for sure. Where else is this thing equal to 0? Yeah, so if I plug a 2 in. So let's see. This would give me 4 times 3 is 12. -2 times 2 is -4. All right, so there's one equation that I've got. And then I can get another equation, yes? Now, that gives me how much information? There's one piece of information. How much more information can I get? Doing the same thing again? One more. And there were how many unknowns? 4. Do you understand how that doesn't match? So in math, and sort of in life, the more unknowns there are, the more information you need. In fact, in math, you need an exact match. You have one unknown, you need one piece of information. 2 unknowns, I need 2, right? Systems of equations. Remember, 3 unknowns, you needed 3 equations, right? I mean, even then, you weren't guaranteed an answer because sometimes somebody gave you information twice. So if I told you, I'm twice as old as you, and then I said, you're half as old as me, did I just tell you 2 things? I'm twice as old as her, and she's half as old as me. I just told you one thing. So that's only one piece of information. Okay, I really want you guys with me. So where is the other 2? Don't I need 2 more things? What else have I not used at all yet that they told me?
The original.
Yeah, the original equation. What's true about the original equation?
It's
Where'd it go? There it is.
6 at -2 and 0.
Yeah, when I plug a -2 in here, I get a 6. And when I plug a 2 in there, I get 0. So then you're going to have 4 equations dealing with A, B, C, and D. That's going to be fun. So have fun with that. That's all I'm going to say. I don't know if did that help somebody at least get started? And again, I still see people looking at me like, what the shit? So is everybody cool with what we got here so far? Right? You do that one more time, but plug a 2 in, yes? Okay. Then, what do I know about this? Well, I know that when x is, what was it, -2, the output is 6. So if I put a -2 in for x, what would y be? Ah, there's another piece of information connecting A, B, C, and D. And you can do that again, because they gave you one more point. So how many unknowns? You got 4, and how many pieces of information do you end up with? 4. Match. You should be able to. Oh boy, some of you guys still look like, oh well shit. Now at least you know what to do.
So you plug in x and y, so then that's 4.
Oh, I really want this to make sense. What did we do here? Tell me exactly what I did to make this.
You plugged in -2.
And?
Point, and 0.
Good,
Get the horizontal
because I
tangent.
knew that y prime has a point at -2, 0.
Yeah.
So here I'm just doing the same thing. I know this has a point at -2, 6. So I'm doing the exact same thing, just with the function itself. So one big thing that's coming out of this problem, and a couple other problems, is you're going to have a function, and you're going to have possibly several derivatives. When they give you information, you have to know which function to use. This one's not that bad because a point the function goes through has to work in the function's equation. Of course, we know that from frickin' algebra. But the new shit is, if I know something about its slope, it's got to work in the derivative equation. Okay, maybe? I don't know. That's all I'm going to say. Some of you guys still look scared, but you should have enough to at least get started. Okay, or maybe? All right. Yes?
Number 53 and 3-3.
Oh, this one, yeah. Somebody else is asking me about this. All right. What does the... All right. Did I turn you on? I think I did. Yes. What's the only thing I currently know for this weird looking equation? I know what y is, yeah. That's it. What else do I need to complete this equation? Y prime, so I can figure out y prime, yeah. And I need y double prime, I can figure out y double prime. And then throw all that shit in, you're gonna get this beautiful... By the way, I haven't said this, but you might find situations where you have to take your paper and turn it like this to do your work. Trust me.
Was this 3-3?
This is 3-3. So number 53.
Implicit differentiation
3.5.
3.5?
Yes.
So we find the derivative and the second derivative, we plug it all in, and it
Yes.
should- it
So
should
what's going to
equal
go right
sine.
here? What's going to go right here?
A
A sine x was because of it. What's going to go right here? Whatever the shit y prime is. What's going to go here? Whatever the shit y double prime is. So it's going to end up being kind of a long ass dude, right?
And we're just proving that it equals sine it? Oh no.
No. Watch. Watch. Here is the thing you need to understand to do the rest of this problem. If I had this, okay, shit. If I had that, sorry, it's just for me. Okay. Can you figure that out for me? What are A, B, and C? Can anyone figure that out? All right, let's stop. Let's stop right there. B is 0. This is a correct statement. Do you see why? In order for this equation to be true, whatever is in front of sine here has to be 0 because there's no frickin' signs. So I know B is 0, yes? What do I know about A and C? A minus C has to be 2. Do you see that? In order for this equation to be true, all the coefficients of cosine must equal 2 when you put them together because that's what it freaking says. Does this feel familiar to anybody? Anybody remember partial fractions? Equating coefficients? I love you guys so much. We're gonna review that pretty soon. Very soon. Remarkably soon. So don't worry, we'll come back to it. But that's the one place, that's the first place you normally get this idea of equating coefficients. It kicks so much ass. So for example, the normal way you have this is, if I had ax squared plus bx plus c plus dx equals 6x squared plus 2. Can anyone tell me what's true about b and d? Can somebody tell me what b plus d must be? Must be 0. Why? There's no freaking x's over there. So whatever the hell b and d are, they must have canceled. So it's like this becomes this. How? B plus d's gotta be 0 because it says they canceled. Do you see that? Yes? Maybe? I love some of you guys are like, what the shit? But please let that make sense. That's all that's saying. What must B and D have been? They must have added a 0 because there's no freaking x's over there. What must A be? 6. It says it's 6x squared, so A must be 6. There's no other x squares. And of course, what must C be? 2. So then you just have to, Anyway, you need more information to figure out what B and D are, but that's the basic idea. Equating coefficients kicks so much ass. Okay. All right, maybe. Go right ahead. Buy, sell, buy. Okay. Let me see. I thought I had more. Shoot. Oh, no. I didn't bring myself much. There we go. My kingdom for paper. There we go. All right. Now, anything else from homework? Think yes? One more thing?
For 33, do you just solve for 0, the derivative?
Are we talking about which section? Sorry.
3.3.
3.3. For what values of x? Yeah. So again, what makes the graph of f have a horizontal tangent line? What must be true? The derivative has to equal 0. Yeah. That's it. You take the derivative, set it equal to 0, solve it. It'll be a beautiful reminder of solving trig equations, right? Oh shit. Yes, sir. Oh, good. All right. I like it. All right. That's enough. Okay. So let's get back into where we left off. We finished the chain rule worksheet, which was, well, it's not the chain rule worksheet, I'm sorry, but we finished this differentiation practice, which included chain rule in a few places. This was a huge thing to kind of make a note of, right? Whenever the function is simplifiable, you freaking do it, right? Because this could be disgusting, but if you just factor and divide, it's fantastic. It just becomes linear, no quotient rule. And then, of course, these two, and let me say this real quick. I'm glad somebody brought this up earlier. If this would have been f of x, f prime would have still been what? 0, because that's a constant. I like it. So we had a little talk about, I was making things y and making things b and making things beta, and I just happened to make those two y, and somebody was like, oh, when it's y, it's always 0. I'm like, no, shit. No. Okay. So it always depends on, is this a constant? All right, so as a teacher, it kind of sucks when I set up a false pattern. I'm like, damn it. All right. So what we're going to talk about today, obviously, is we're going to talk more about to get ready for this weird shit. Let's do that. And I kind of gave you a quick example at the end of the last class. All right, so an example to get into 3.5. So I'm going to kind of redo what I did. If this is what I have, what is f prime? Yeah, there's 6. Where's 6 coming from? Times the derivative of the inside, which is nothing. All right. Well, let me do this. Times the derivative of the inside, which is 1, right? Which is why it doesn't really show up. Is everybody with me? So you really do always do chain rule. You just don't need to show it unless the inside's more than just a linear thing with a slope of 1. Okay, gotta be okay. So let me make this a little more interesting. So what if I had this? Just a little tiny bit more interesting. What would G prime be?
Times x squared plus 3x times 2x plus 3.
Right, and then by the way, I'm not kind of finishing these, right? Because we could do it. That's not the point right now. So that problem's not done. You guys with me? But there's a point I'm trying to make. I don't care if you finish it, whatever. And if you remember what I did last time, it's the same point I'm trying to make. So what if it was this? What do you got, Jeff? What would H prime be? I made that worse than I wanted to, but oh well. 11 times sine 4x to the 10th times. And of course, this would be kind of more involved, right? Because it has its own chain rule. Okay, and again, right now, I don't care. So the point I'm trying to make is, every single one of these had some function of x to the 11th power, and it was always the frickin' same, correct? Every single time I did it. That doesn't mean the answer was the same, but the work I did. 11 times shit to the 10th times the derivative of shit. I like it. Okay. So, if my function had actually been this, that's a y. Y is a function of x. That is a stand-in for anything it could be. Y could be x plus 7. Y could be x squared plus 3x. Y could be sine of 4x. Y could be natural log of tangent of inverse cosine of 4 over x times natural log of 3x. Right? Whatever the shit. It doesn't matter. How would I take this guy's derivative? You could do it. 11 y to the 10th times y prime. My little prime got really excited, but oh well. All right, now this doesn't feel ground shaking. And I kind of want to design it like that. This is kind of silly, right? This is just capturing a general kind of rule. If I got shit inside, I got to remember to take its derivative too. That's really all I'm saying here. Now, what does that lead to, though? What that leads to is the ability to do, let's do this. Can somebody tell me what this is the equation of? Circle radius 3 centered at 0, 0. I love it. Okay, so if you want to write that down for yourself. Yes?
How did they look at that and got that answer?
All right, so that's not, okay. They remembered, to be honest, let me ask somebody, how do you guys remember this? All right. I love that answer. That was awesome.
Yes.
I just know shit. That's what I do. I sit here and I know shit. Somebody else give me like, did you memorize the form of a circle? Did anybody do that? Or
Yeah.
yes, right? All right. I'm sorry. And again, so some people memorize the form of a circle. Some people maybe remember unit circle kind of stuff. But the main idea is real quick little side note. A circle. The definition of a circle is from the center to any point on the circle is the same distance, right? So real quick, I'm just going to go through this real quick. What's any point on the circle? X, Y. Is that cool? Any point on the circle is X, Y. What is the distance between 0, 0 and X, Y? We're going to call it R. So how do I figure out the distance between X, Y, and 0, 0? Does anyone remember? Pythagorean Theorem, well, sort of. So it's the square root of x minus 0 squared plus y minus 0 squared. And that would equal the distance. Okay. So then you can square both sides and you get this. Now this is centered at 0, 0. If it was centered somewhere else, there would be like an x minus something and a y plus something or whatever. That would move the center around, correct? Well, that would move every point around, so, okay. All right, I like it. And of course, you could even, I think this is what you meant, a slightly better way to look at this is this triangle here has got x and y, so x squared plus y squared equals r squared, and then you got it right there. Even better. Now, so that's how I know r squared is 9, so I know radius 3. X and y haven't been shifted, so the center is at 0, 0. Kick ass. I want to take this guy's derivative. Would everybody agree that a circle at some point has a tangent line? Any point? Yes? That means I have to be able to take its derivative. Is a circle a function?
No.
No. But calculus don't give a shit. Calculus just says, hey man, give me any kind of weird curve and I will tell you what the slope is at a point. That's one thing calculus says. It says a lot more, but that's all we know at the moment, right? Okay, so I need to be able to take this. Could I really solve for y?
Yeah.
What happens if I try to solve for y? I take a square root, which means I have to put a plus or minus, yes? Okay, so this is kind of cool. Okay, here we go. The thing we got to realize about taking derivatives is it's independent of where things are. I could just take the derivative of both sides. When is it the easiest? If it's solved for y, because what's the derivative of y? Y prime. You with me? If it's solved for y, that's when the derivative is easiest. So remarkably enough, that's what we start with, just to learn derivatives. We start with, it's already solved for y, so we can just learn derivatives. And then we go, oh shit, what if it's not only not solved for y, what if you can't really solve for y? I know there's a freaking slope, but I know there is. So I've got to still be able to take a derivative. So what's the derivative of x squared? 2x. And by the way, I want to try to sneak in. Is this the right place to do this, Jeff? Maybe. We got to bring d by dx back in. We got to get used to that again. So I'm going to kind of do both for a little while. I've been sort of purposefully not doing that just so we can worry only about rules of derivatives. But now it's going to become more and more important to remember the other way to represent derivatives. So I can represent y prime as f prime of x. I can represent that as dy dx, and I can represent this as df dx. It's kind of accepted that we can just put an f instead of f of x just to make it quicker to write. Okay. So watch this. What is the derivative of x squared? 2x. What is the derivative of some function squared? 2y dy dx. Right? This is y prime, yes?
Yeah.
And again, you could put a y prime there. I'm just going to start to bring it back into some problems. We got to get used to it. And what's the derivative of 9? 0. Can you solve that real quick for me for dy dx? Please, take a minute. Solve. Look at dy dx as a variable. You're trying to solve for it. Go ahead. I'll just stand here and look at you. And again, just to show you, in case anybody's, let me do this the other way. This is the same thing exactly, right? That's exactly the same thing. Yeah, so let's see. Subtract 2x, subtract 2x. Let me come back to this guy. So this would be 2y dy dx equals negative 2x, yes? And then I divide by 2y. So dy dx, the derivative of the function of y is negative x over y. Now let's make some sense out of this shit. Let's make some sense out of this. Let's look at this. So again, so here's the derivative at any point. Let me write it like this so it's just, it doesn't matter, Jeff. Okay. Let's look at this circle again. That's not bad for me. All right. What should the slope be here? 0. What point is this?
1, 0,
0.
R. Radius.
Yeah, but what was the radius?
3.
3. Okay. We got. This is still the one we're talking about. Yes, ma'am. I love it because. So I love what you're saying right now. For x equal to 0, right? X equal to 0, it could be this or that, right? Is that what you're saying?
Yeah.
I love it. Or if I wanted this slope, that would be this x, but does that refer to this or this? Now, here's what's really cool. What is different about this derivative? I don't just plug in for x, I also plug in for y. So then I could be very specific about exactly which point I want. Does that make sense? That kicks so much ass. We are not used to having multivariable equations like this. Yes? But this is beautiful. This is what, just imagine if there's not a function, if it's like this, you want to be able to throw the whole point in for exactly what Zoe just said. If I just plug an x in, well, which frickin' place? It's x, it's like 3 in a lot of places if it's doing this shit, yes? But if I could just plug in a specific point, meaning I need a place for x, I need a place for y. If I throw that whole point in, I'm being very specific about where I want to know the slope. If it's a function, why do I just have to plug x in? Because function has only one output for each x. That's by definition, yes? That's why I only have to plug an x in, because I know exactly what I'm talking about then. If it's not a function, shit! X could go to many places. So this kind of makes sense. If it's not a function, the derivative has to have a place for both x and y. Does that make any sense to anybody? This is the first time we've really seen this, but I want to show you how it completely makes sense. So, if I want to know the slope at 0, 3, what do I put in? And let me show you some. All right, let's see. I'm throwing a lot of notation at you today, but that means slope at 0, 3. The little line means evaluated at 0, 3. This would equal negative 0 over 3, which is exactly what we said it should be, yes? We knew it's supposed to be flat there. What should the slope be here? Infinite. And of course, that point is 3, 0, and that would just be this upside down, which would be undefined. Infinite. Is that cool? If I put 3, 0 in, it would be 3 over 0. Negative, but who cares? Okay, maybe. All right.
It would be negative? Could you come from the bottom of the
How do you mean? Sorry.
like
So watch this. This is kind of neat. So as I move around the circle, isn't that negative infinity?
right, but could you come from the bottom?
Not the way this is defined. No.
Okay.
Yeah. Okay. Now, what about if I want to know the slope there? 45 degrees. I'll put the reference angle there. Right. Let me make sure you understand referencing. All right, tell me what that is. Take a few minutes. What is the slope there?
1.
Okay. Yeah, well, this shouldn't be that hard. I appreciate that. Does that make sense? Why was that so quick? Because what's true at 45 degrees about the x piece and the y piece? They are the same. They are weird looking, right? They're rad 2s and all this kind of shit. But they're the same. And what is the slope? It's the ratio of those negative. So the x would be negative something, and the y would be positive same thing. They cancel, the negatives cancel, you get a slope of 1. Maybe? Maybe? Here, let's do it for real. Let's do it all the way. What is this point? How would you figure out that point?
Negative 3 root 2 of 2.
All right, so the weird thing is, I see what you're doing. I think you're building it in.
I'm using the unit circle. Like
Yeah. So the unit circle would say, how do I say this? Yeah, let's do this. Sine of theta is equal to y over r. So y would be radius times sine theta. I love you guys. Right? So therefore y would be 3 times sine of, I'm going to go ahead and put the reference angle in just because I know it's positive there, right? Sine of pi over 4 is rad 2 over 2, so this will be 3 rad 2 over 2. X will be 3 times cosine, right? Negative, because it's back. So you get negative 3 rad 2 over 2. And when you take their ratio, right, they cancel each other out, and the negatives cancel out. So you do end up with, let me see. Oops. Equals 1. So that kind of, there's no way to really know for sure, but that sort of makes sense there, right? Looks like it's a slope of 1, possibly. Yes?
Isn't that not where pi fourths is?
For what?
Pi fourths, like just in the unit circle, shouldn't it be that flipped over the y-axis?
How do you mean, sorry?
Like where you drew it, like shouldn't pi fourths be the other side? Like What you drew is like 3 pi fourths, right?
All right. What does RA mean?
Referencing.
Yeah, so this is 3 pi over 4. And the reference angle is pi over 4.
Oh, okay.
Yeah, I like it. I always bring it back to the first quadrant because those are what we have memorized. All right. I could feel everybody, whenever trig comes up, everybody's like, okay. All right, so let's do a different problem if I can find some paper. Bum, bum, bum. All right, I got a little piece of paper. Okay. All right, let's get away from trig for a minute. Trig-related stuff. Okay. So what about if I had this? All right. Does everybody agree with me that there's no way in hell you're going to solve that for y?
No.
All right. I want you to do it, please, and then show it to me, because I feel like it's what was in that briefcase in Pulp Fiction. Is this equation solved? Oh.
Yeah.
Now, I mean, all right, let me be more specific. At this level, we cannot solve this for y. There are methods you could use to get something, but I mean, how could you free this guy up without getting him stuck in an ln, right? So there's no way to kind of free them both up at the same time. You can't solve this for y. But, so when you graph this thing, it's going to be some kind of a neat, kind of curvy dude. It could be anywhere it wants to be. It doesn't have to do like a function. It could kind of come back on itself. It probably does. Okay. But we are now able to take this guy's derivative all day long. What rule happens here? Product rule. So if you want to, you can write, x prime y plus xy prime. You don't have to. I'm just going to write the rule out. What's the derivative of e to the y? Almost. Times y prime. Anytime the inside function is more than just x. And this is called implicit differentiation because y is implied to be a function of x. I just don't know what it is, right? Because I can't solve this damn thing for y, so I don't know what the function is. And of course, derivative of 2x, 2. So just think of y as a stand-in for x squared plus 7 or sine of 2x or something, right? And you would do chain rule if it was e to the x squared plus 7, wouldn't we? Right? If it was e to the x squared plus 7, and I had to take this guy's derivative, you would do the chain rule, correct? Mm-hmm. And what would it look like?
E to the x squared plus 7 minus 2x.
I love you guys, yes. But I'm going to write it like that. So what if this was y? It would just be a freaking y in there, which is exactly what we got. So the y is just a stand-in for whatever funky-ass function this actually would lead to if I could solve for y. I just know what the shit it is. Okay. What do you think I do? Well, what's x prime? Okay, so let's write this again. All right. Now, what do you think my next thing to do is? Solve for y prime. I love it. And this is where people forget their basic algebra. Yes?
I'm sorry. I got lost. How did the x get out? Meet the other side of the
Here?
yeah.
So what am I doing to both sides of the equation? Yes. So this is the thing. You know this from algebra. If I do something to one side, I better do it to the other side, correct? So if I take the derivative of one side, I better take the derivative of the other side. That's kind of awesome. So we're expanding our understanding of what it is when we take a derivative. Normally when it's just solve for y, we don't even have to think this much about it, just as y prime. But now if I can't solve for y, I've got to really say, oh, I am taking the derivative of both sides. So each piece has got to be taken the derivative of. Yes?
On the second line, where it says e to the y times y prime. You put y prime because of the
Yeah, so that's what this example here is about. If I have a function of x up here, wouldn't I do the derivative of e, let me do this again because I wrote all over this, times the derivative of the inside function, right? No matter what this inside function is, if it was more than just x. So what is the inside function? It implies there's something there, but it just tells me it's y. It doesn't know. So what I have to multiply by y prime. It's kind of like just the definition of chain rule, right? E leaves the same times the derivative of the inside function. Okay, I love you guys. I want you to remember how much shit you know now that you did not know, right? And this is something we are learning for the first time. This always trips people up a little bit because it feels kind of familiar and at the same time it's very different. I understand that. How do I solve this for y prime? What do I want to get the hell out the way? Freaking y, because it didn't have any y primes. So get out of here. And then, of course, factor a y prime out. And then there. So that is the derivative at any point on this graph. Now, here's what's interesting. Does everybody understand that I can't just pick any x and y that I want? Why not? I can't just plug a 3 and a 4. Yay!
I just have a question.
Oh, okay, real quick. Anybody? Why can't I just throw a 3 in for x and a 4 in for y?
It has to be going along the
Yeah, it's got to freaking work in this equation. This is the equation that sets what the points are that I can use. Isn't it much more difficult now to find points? It's not solved for y, so it's not nowhere near. But for example, can you guys verify for me that it goes through this point? Jeff. It goes through this point. There we go. Do you guys see that?
Yes.
Because if x is 1/2,
Oh, yeah.
that's 1, and if y is 0, that's 0, and that's e to the 0 is 1. So that it definitely goes through that point, right? So then if I wanted to know the derivative at that point, I would just throw, so again, you could do this. Just throw a 1/2 in for x and a 0 in for y. So it'd be 2 over 3/2, 4/3, is that right? I believe that is right. Okay. Okay. Funky, funky shit. So let's do this. Yes.
What does that mean exactly?
So that means whatever this function looks like, whatever it looks like, right? And we're actually going to develop. Actually, I think you did this in 176. You develop some. Do you remember parametric equations and stuff like that? No. Parametric equations. Anybody?
It
Sounds familiar? Where you let x was a function of t and y was a function of t. We are going to talk about that, so we'll review that a little bit. Yeah. Polar equations. Remember the polar? R equals 2 sine theta. Really? No? Okay. All right. We'll review those because we're going to take derivatives of those things. Anyway, sorry. What that means is at the point 1/2, 0, this function has a slope of 4/3. The tangent line would have a slope of 4/3. So whatever this thing looks like, it's curving right through that point at a slope of 4/3. That's what that means. Just like on the circle, which is much easier to look at, because I know what that looks like. I have no freaking idea what this looks like. Okay, so let's look at this. Everybody's got this sheet. Again, let me make sure anybody need this sheet that we worked on last time. Let's see if I can get a key point for myself today. All right. So let's do this. Let's go kind of one by one through this. Go ahead and do part A. And I guess for right now, just you can use the prime notation. I don't want to, again, I'm going to try to start bringing dy dx in more often. But, for now, you can use the prime notation if you want to. That's pretty cool. All right, let me see. So here's the, there are two fringe benefits to writing the rule out. One of them is to help you focus on just the piece you worry about at that moment. So you don't feel like you have to have the whole thing in your brain at once. That's insanity. The other reason that writing the rule out is cool is because you don't forget to do your y prime, for example, right? So that's just y prime. What's the derivative of cosine? Is everybody cool with this then? And then times the derivative of the inside, 11. Anytime the inside is not just x, it has to show up. Oh, this is great, Jeff. I really give you guys so much room for these things. Equals, let me do the other side here. What's the derivative of 3x?
3.
Holy shit. And then 2y squared.
4y.
The 2 comes down, times derivative of the inside. I like it. Oh man, I'm zoomed in. I really want you, I really desperately. Y is a function of x. So if it's inside something else, it is a chain rule. It just is. Again, it's a stand-in for x squared plus 7 or natural log, whatever. I keep saying natural log, but today we're going to talk about what the hell that guy's derivative is. We don't even know yet. Okay. So now I can come back. Of course, I mean, some of you guys probably didn't even write this. You just wrote what it was, but that's going to be 2x. Let me put the y prime out front just because. All right, so I just kind of did something and collected some stuff. And now what do I try to have happen? Yeah. I want to get all my y prime stuff on one side. And everything else, that's good old algebra, right? Get all the shit with the thing you're trying to solve for on one side, everything else on the other side, right? So I'm going to basically take that over, and I'm going to take that over. So I get like that. Is that cool? The 2xy subtracted over, the 4y prime subtracted over. And are you guys cool? Let's see if you guys are cool with this. This always kills me if I can't just write this. So it's going to be this divided by all the shit in front of the y primes because I'm going to take a y prime out and then divide by the other shit. Yes? X squared plus sine y minus 4y. Woohoo! That's horrific, Jeff. Really slam that thing in there. Okay. Now, just so that last problem we did, we came up with the point because it was kind of easy to kind of pick something that made part of it 0 and shit, right? Could you easily find a point that this goes through? Do you understand what I'm saying? Could you easily find a point that this goes through? Are you guys trying to do it or
Yeah.
Okay, I see. Okay.
I don't think so.
Not easily. You could kind of be lucky and happen on something. You always try to make something 0. But in this case, if you make y 0, what's cosine of y? 1.
Yeah.
So then you could say, okay, y 0, that's 0. If y 0, that's 0. And then you can solve for x. So you could do it because, do you see what I'm saying?
Yeah.
So if you had to come up with a point, I always start with throwing zeros in and just seeing if I could solve for something else. But I could very easily make something that would be basically impossible for you to find a point. So thankfully, that's not part of what you need to be able to do. They will normally ask you, what is the derivative at this point? They're going to give you a point. So what? Okay. Is anyone, how are you guys feeling at the moment about this? Roughly okay? Huh?
Poopy.
Poopy?
Yeah.
Okay. All right. I need to have little things you can hold up. I don't know if some of my colleagues have said they had little red things and green things and whatever. I feel like this. I feel bad. Yes?
How'd you get the y prime out of the 4y?
So take a y prime out, and then it'll be y prime x squared plus sine y minus 4y, yes?
No, farther up.
Oh, here? What? Where?
For the 3 plus 4y y prime.
Oh, here.
Yeah.
So what's the derivative of let's see. What's the derivative of 2 times, what do you got, Jeff? 4x squared plus 3x squared. How would you do that derivative?
You would bring the 2 over.
Good, 2 would come down. And then what? Times what?
Oh, what's on the inside?
Yes, the derivative of what's on the inside. Yes?
But how would that
No,
work?
no, watch. Wait.
Okay.
I really, is that
Yeah.
perfect?
Yeah.
So let me just say, what if I just say, all right, just some function, I don't know,
Oh, okay.
right? That's the whole point of this.
Yeah.
Just some function, I don't know. It could be x squared, 4x squared plus, I don't know. It could be sine of 3x, I don't know.
Okay.
Just some function. The 2 would come down, and the derivative of the inside.
Okay.
It is just the very direct writing of the chain rule. It's almost like the definition of chain rule that you keep writing. Times the derivative of the inside. Times the derivative. Okay. I like it. All right, sure. Try. Here, let's try part C. I think part C is not that bad. Yes.
I have a question on that part. How did you get up this before from the x squared prime y? Where did the x squared y prime come from?
Oh, product rule, right?
Oh, wait.
Yeah. Derivative of the first times the second, and then first times the derivative of the second. Yeah.
Okay.
So it is x squared, which is a function, times another function. Yes. I like it. Yes?
I'm gonna sound really dumb asking this, but how did you get the -2 x
Oh. So I want everything with y primes on this side because I'm trying to solve for y prime, right? So I'm going to subtract this over, and I'm going to get rid of this. Subtract that over.
Oh,
Yeah. Okay. Yes.
Can you explain again where that y prime went on the denominator? When you took out the y prime and it would be like an else?
All right. Let me see. I think I have more of these somewhere, hopefully. So again, I skipped this step here. Right? Is that cool? Let me see. Let me put this up here.
Yeah.
See that step? So then I'm going to divide by this.
Oh, okay.
And so y prime is still, yeah. So whenever I get this, whenever I get all my stuff together, you guys okay? Everybody? Okay. Minor, all right. When I see this, I just know the y prime, and I'm going to divide by all the shit with y prime, because that's what's going to happen.
Okay.
Okay.
It makes sense. I just didn't see.
No, it's fine. I don't want to throw too many of my weird-ass little shortcuts to you guys. Let's do part C real quick. That's maybe going to be a little better than part B. Can somebody tell me what part C looks like if you were to graph it?
Circle.
Circle with center somewhere other than 0, 0, yes? Because you would have to do, right, if you subtracted 2y over, you could then do completing the square to figure out y minus plus something squared, blah, blah, blah. So at least we know the center is not 0. And then the radius of whatever the hell happens. But, okay, so try to take that guy's derivative. We'll do this here in a minute. Take this guy's derivative. Maybe I could do that here. Yeah. Yeah. Another load. Okay. Paper. All right. I think you guys know enough to know that part B is going to suck a lot, and part C is definitely one of the easier ones. Yes? Hopefully. So how do you take this guy's derivative? This is going to be 2x. Good. 2 comes down times shit times the derivative of shit. Okay. And I'm really sorry if I offend you. Just wait a minute and I'll do it again. I actually had a student say, "Can you just not cuss?" And I said, "I'll do as much as I damn well can." So, and what's the derivative of this side? Got to be a little careful. Good. 2y prime. Okay, let me stop for a minute. Is everybody?
Why do you have 2y times y?
All right, again. Why is this one just 2x? Because the inside is just x, right? And the chain rule only has to show up when the inside is not just x. What is the inside here?
Y.
Which is some function of x, right? Y equals, I don't know. It didn't tell me. That's why it's called implicit, implied. So what's the derivative of something squared? Isn't it 2 times that something times the derivative of the inside? I like it. And then, of course, this one's not nearly as bad. The derivative of y is y prime. Bam. And just to show you, real quick, don't write this down. This officially would be 2x times x prime plus 2y times y prime equals 2y prime. But what is x prime? Yes, okay. So that's what I keep saying. Chain rule only has to show up if the inside is more than just x. Because it's the only time the chain rule is going to be times something other than 1. If the inside's just x, the chain rule is just going to give me 1. Who gives a shit? Okay. So the more you understand chain rule, the more you understand implicit differentiation. And I'm almost certain some of us are like, well, I don't understand chain rule yet, so, all right. But you at least understand it enough, I think. All right, well, I'm going to keep going. And then what do I have to do? Can I just kill the 2's? You guys see that? Die, 2, die, just get out of here. All right, so let me write this again. Sorry?
What about plus 3?
Plus 3? Oh! So again, yeah, what's the derivative of any constant? 0. It is. But again, Kayla, don't forget, all derivative is slope. What's the slope of y equals 3? What's the slope of 3? It's flat, so the slope is 0. That's why any constant just goes away. It doesn't really go away. Its slope is 0. So it doesn't show up. Okay. I love that reaction, though. This whole class is ridiculous. All right. Now what do? You want to get all the what together?
Y prime.
All the y primes together, because that's what you want to solve for, right? So let me just subtract this shit over. That's the only y prime that's not together. And then just to show all the steps, I can then factor a y prime out, and what's left?
1 minus 1.
1 minus y. Okay, and then I just divide by 1 minus y. I really want you guys to remember, what was the derivative of a basic circle? Negative x over y. Doesn't that look very close to it? It's just been shifted a little bit on the bottom? All right. Because the circle's been shifted a little bit. That kind of makes sense. Kind of. And all right. I'm going to push my luck a little bit here. What was the other way to write y prime? dy dx. All right, let's talk about this for a minute. Okay. This, of course, is... You guys remember what this really takes the place of from algebra? Delta. Delta means a big step. And a big step could be a step of 0.000001, because compared to infinitesimally small, 0.00001 is gigantic. Okay. This means the smallest possible step over and the smallest possible step up or down, depending on what y is doing. Are you guys with me? So that's why we make delta. I always think, when I see delta, I think, well, either the word gross or crude, but big, a big step. And when I see d, I'm like, oh, there's the tiniest damn step, tiniest little damn step. When I see this notation, the variable is assumed to be x. I'm taking the derivative of this function with respect to x. Let me write that down, because that's huge. That's how you read this. This would be the derivative of y with respect to x. What the hell does that mean? That means, fundamentally, that means, how does y change with the change in x? And of course, that's slope from algebra, right? Which explains why. This is something I was talking with somebody about earlier. If I see a function with no x dependence, where is that freaking thing? Do I have it right here? Of course I don't. Yes, you do, because it's on the other side. Remember these? This problem? Does this side care what x is? So, if I change x a little bit, how much does that side change? Not at all, because it doesn't give a shit what x is, right? So that's why, of course, that's why it makes sense the derivative is 0, because there's no x dependence. So if I change x, does that change at all? Of course not. Okay, I like it. Same thing with this dude. Now, oh man, this might be... Where'd you go? Here it is. We're going to try this. All right. Yeah, this is in this section, so I might as well throw this at you. Here we go. All right, let me write this problem again. All right. Now here's why I'm trying to bring dy dx in. I'm going to redo this problem using dy dx instead of y prime. I just am. Okay, here we go. So this would be 2x plus 2y times dy dx equals 2 times dy dx plus 3. I think here's where we killed the 2's, right? Well, get out of there, 3. There's the whole discussion you just had, Jeff. You're awesome. Kill the 2's. So x plus y dy dx equals dy dx. Subtract the y stuff. Then I can pull out a dy dx. So do you guys see how this is exactly the same? Just putting dy dx instead of y prime? Okay. So some of you guys are like, why the shit are you doing all this stuff? Okay, there's obviously a reason. I'll remember it hopefully in a second. Oh, yeah. Okay, same thing. Now, let's see. This is why this notation is so important. I really want you guys to start realizing, did we have to consider y over x? Couldn't we instead consider how does x change as I change y? Couldn't we have instead thought of it that way? Couldn't we have done all of algebra like this? Isn't it arbitrary? It's completely arbitrary to set these up, like completely arbitrary. I just like to say the word arbitrary. All right. Now, I really want you, this is going to, okay. This is so cool, though, in a second. You're going to hate it at first. So what I want to do now is take the same thing, but I want to know what the shit dx dy is. And again, this is not a big deal. This really isn't. We got to let go of this is always y, this is always x, and it's always y affected by x. No, it could have been the other way around, totally. Because we just got to do this, and then that's what it is, right? So, holy shit. Almost, you're like down a leg, you're almost down an eye. Let me stay back here, because I'm dangerous. I got to put a little sign there saying pen zone. So, if I want to do dx dy, what is my variable now, according to what I'm taking the slope?
X prime.
All right, let me try again. Yeah, x prime is what I want to get.
Okay.
On this problem, what was the variable? X. On this problem, what's the variable? Y. Yes?
Sorry, I was just trying to so it's basically just stating like x is some function of y.
Yes. Which of course we could do, right? If I have y equals 2x, isn't x equal to 1/2 y? That's all I'm saying right now is it was arbitrary for us to pick y to be the guy that is the function of the variable. We can not always, but we can rewrite it to be x is a function of y. Of course we can. No? I love you guys. You guys are all like, just do it and get it over with. Okay. So now, x is a function of y. So what is the derivative of x squared?
2x times x dx dy.
And I really, now watch. Let me see. I'm going to try to do too much at once, but that's okay. I'm going to restart this in a minute. So let me do something a little weird right now. So wouldn't this be 2y? I really want this to make all the sense. Times dy dy. Do you guys understand that? What's the inside function here? Y. So wouldn't this be dy dy? Isn't that 1? I love you guys. I'm trying to do a lot of things at once, and I'm sorry. But where's that thing I just did? Darn it. Do you guys remember? Are you still right here? No. All right, let me do this. Don't write this down. Do you guys remember when we were doing it for dy dx? And I said, wouldn't this be x squared times, 2x times x prime? Remember that? Plus shit, yes. And this was kind of silly to write because it's just 1. But what is x prime? Isn't it dx dx in this case? Right? I'm doing d stuff dx on this problem because I'm considering x to be my true variable, my true independent variable. Okay. So up here, I'm taking the respect to y. So this dx dy is not just 1, but now dy dy is 1. Okay. So what's the derivative of 2y? 2. Good, because I'm taking respect to y. This is why the d by dx stuff has a purpose. It definitely helps in this kind of situation because this is dx dy, so I'm taking respect to y. So y is what I'm assuming my independent variable is. Just stay with me now. Is everybody semi with me? Do you see how it just sort of changed where the prime thing is? Okay. I can kill my 2's just like before, right? All right, so now this is a 1. So let's see, I got x dx dy plus y equals 1. And what do I want to solve for? Dx dy. So I'm going to subtract y. Is this cool? And then I'm going to divide by x. Now, here is something. All right. Become a thing. There we go. Now, do you notice something between? Isn't this what we got before? I was kind of hoping somebody would go, isn't it just going to be frickin', if you want dx dy, wouldn't it just be 1, 1? Well, yeah, it is. We just proved it. Isn't that kind of cool? So if you're asked this question, you technically, I'd really rather you not necessarily, because I need you to get used to thinking this way, but you could solve for this and then just flip it. You totally could. And young Jeff himself might have done that and been told, no, you got to get used to doing that. I'm like, all right. Yes?
So, sorry, so isn't it just fundamentally the same exact thing, whether or not you switch it over or not? Like,
Yes.
like I could put C or F.
Yes,
and
totally.
That and it doesn't
Yeah. In fact, what you really could do is just switch the x and y in the first place. Okay. So really, all this is saying is, I don't know if anybody thought of this back in the day or at any point when you were finding the slope of this equation. It's 2, but that means it's 2 because for every one step over, you go 2 up. And this is the y-intercept, right? But the whole frickin' thing, if I had this would be the x-intercept, yes? And this would be change in x over change in y, yes? Yes?
So it's kind of like the inverse.
This would be dx dy. Yeah. So of course this would, if I do dx dy here, it would be 1/2, right? Okay, maybe. I love you guys. I love you guys so much. So let me make a better one. Here, hold on. So y equals, what do you got, Jeff? Yeah, 2x minus 4. If I solve this for x, don't I get 1/2 y plus 2? Somebody check me out. Aren't those the same thing? What's the slope here? It would be dy dx, yes? The change in y over the change in x would be 2. Dx dy of this guy would be what? 1/2. I kind of noticed that. I didn't have a teacher that told me this, but we kind of completely arbitrarily decided how to determine slope, and not really arbitrarily, it matches perfectly with physical reality. Flat should be 0, correct? Straight up and down is not necessarily something you want to climb. If it's straight up, right? Let's go for a walk. Oh shit, right? So that kind of physically, the slope we decided to define it matches with physical slope. But we could have totally just decided it was change in x's over change in y's. And then we would have had x equals my plus b, where the b would be the x-intercept. Yes? Maybe? Damn, I went further than I was really needed to, but that's all right. These things happen. Okay, all right. What time we got? Ooh, look at that. I got like 10 more minutes, really. All right. Sorry. At this point, I've completely lost my marbles. There we go. Okay. Look at these two problems. There's one word I want to define real quick. I mean, how would you do this problem? Yeah, find the derivative. So solve this for dy dx. Then I can plug in 4 for x, 2 for y. So it's not that different at all from earlier find the equation of the change in line problems. It's exactly the same. Just finding the slope is a little more complicated, which makes sense. The one thing we don't know yet is what the hell this means, right? That's something in math and in life. We want to know what that means, right? So anybody know what that means in the context of this question? Anybody ever run into this before? The normal? So tangent means horizontal, normal means perpendicular. What's the perpendicular slope? So if my slope is -3, what's the perpendicular slope? Does anyone remember? 1/3. So if you get part A done for this, part B is easy. So it's going to be the negative reciprocal of the slope you find here. Maybe. So a tangent line means it comes in and hits that point once and keeps going. Normal line means it comes in at a 90-degree angle into the function, right? So here would be a tangent line would be, a tangent line would be this, and a normal line would be this. 90 degrees, right? So tangent is kind of parallel to that surface, and normal is perpendicular to that surface. That's all that means. Okay. I'll stop torturing you guys. That's enough for today. So that was section 3.5. I really hate... I did just say that, didn't I? That's okay. Whatever I do now, I could do very quickly at the beginning. That's fine. So next time, the very first thing we'll do is figure out what natural log's derivative is, right? Of course, the very, very first thing we're going to do is what? What are we doing next time? First thing. Quiz, yeah. And you want more grades. If you don't know this, you want many grades in any class. So you're welcome. And then after that, we'll do natural log, and then we'll see how far we can get. All right. And of course, the test is. Anybody remember? A week from this Friday. Dude, yeah. If I remember correctly, you can double check me. I'm pretty sure that's right. I'm absent-minded, so I could be wrong.
And all of chapter 3?
2.8 through, and I think it's all of chapter 3, yeah.
All of chapter 3?
Yeah. So somehow we're going to finish all of chapter 3.
In a week.
Dude! We can do it. That's it, guys. Sorry.